Have you ever wondered how glaciers, these massive rivers of ice, move? Picture this: vast icy landscapes stretching as far as the eye can see, their surfaces gleaming and sparkling in the sunlight. These are glaciers, some of Earth's most majestic and awe-inspiring natural wonders. Born from countless snowfalls compacted over many millennia, these icy titans encapsulate an otherworldly beauty that leaves us spellbound. Yet, behind this ethereal facade lurks a mystery that has long captivated scientists and adventurers alike: the movement of glaciers. Yes, you heard that right. Glaciers, despite their enormous size, are not stationary. They're continually on the move, albeit at a pace that makes a snail's race seem like a sprint. The intrigue around their movement is not just about the how, but also the why. What forces compel these colossal ice bodies to shift? What role does this movement play in our planet's grand scheme? Now, you might be thinking these giant ice blocks are static, but you're in for a surprise. Contrary to what you might think, glaciers are not static. They are in constant motion. These colossal bodies of ice and snow are not just sitting there frozen in time. Beneath the surface, a fascinating dance of physics and geology is happening. Let's delve into the science of glacial movement. Imagine a glacier as a massive, slow-moving river of ice. The weight of the accumulated ice and snow pushes the glacier down the slope, leading to its movement. It's a bit like squeezing toothpaste from a tube. The pressure from the top forces the paste, or in this case the glacier, to move. Now let's introduce two key concepts that explain how glaciers move: basal sliding and internal deformation. Basal sliding refers to the process where the glacier slides over the ground beneath it. The pressure from the overlying ice and snow causes the ice at the base of the glacier to melt. This creates a thin layer of water that acts as a lubricant, helping the glacier slide more easily. On the other hand, internal deformation is about how the ice within the glacier deforms and flows, much like a very slow-moving river. The ice at the bottom of the glacier is under tremendous pressure. This pressure causes the ice to behave more like a fluid than a solid, allowing it to deform and flow, contributing to the glacier's overall movement. So, how does all this play out in real life? Let's consider a glacier in the mountains. The weight of the ice pushes it down the slope, aided by the thin layer of meltwater at the base. Meanwhile, the ice within the glacier deforms and flows, helping the glacier inch its way down the valley. Over time, this process can carve out valleys, reshape landscapes, and leave behind stunning natural features when the glacier finally retreats. So, in essence, it's the gravity, pressure, and the unique properties of ice that enable these mammoth ice bodies to move. The science of glacial movement is truly a testament to the power and complexity of our natural world. Glaciers, though seemingly static, are dynamic and constantly in motion. Today, we've unraveled the mystery behind their movement. It's not magic, but a symphony of science at work. The weight of accumulated snow and ice forces glaciers to move, ever so gradually. This movement is further facilitated by two key processes: basal sliding and internal deformation. Imagine a colossal ice sculptor working tirelessly, carving and shaping our landscapes over the span of thousands of years. Basal sliding is when the glacier slides over the land beneath it, lubricated by a thin layer of water. Internal deformation, on the other hand, is when the ice within the glacier moves, deforms, and adjusts to the underlying topography. So when you gaze upon a glacier, see beyond its icy facade. Remember, it's not just a chunk of ice, it's a living, moving entity, shaping our world 1 inch at a time.